Question number 19a. Define half-life as used in radioactivity. So we can say half-life is the time taken for half the number of nuclides initially present in a sample to decrease. So we can put that down. So we can say half-life is the time taken for half the number of nuclides. This is nuclides initially present in a sample to decrease. So that's how we define half-life in radioactivity. Question number 19, part B. Figure 13 shows a device used to detect radioactivity by forming tracks when air is ionized. So we have vapor, radioactivity source, we have tracks, we have gas and dark screen. We have the piston. So state the name of this device. So this device is known as expansion crowd. This is O, expansion crowd chamber. Part B, Roman number 2. State how air is in this device, the device get ionized. So the air get ionized due to collision between the radiation from the radiation source and the air molecules. So you can say due to collisions between the radiations from the radiation source and the air molecules. And the air molecules. So that is how air get ionized in this case. Part C, Roman number 1. State two factors that determine the speed of the photoelectrons emitted from the metal surface. So the two factors, we start with the first one, the work function of the metal. So we can say the work function of the metal. So that is one of the factors. 2, we say energy of incident. Energy of incident radiation. That is energy of incident radiation. Or we can say frequency wavelength. So those are the two factors that we can give, which determines the speed of the photoelectrons emitted from the metal surface. Number 2, the energy of a photon of light is 2.2 eV. Electronic charge is 1.6 times 10 to power minus 19 coulombs. So, and Planck constant H is 6.63 times 10 to power minus 34 joules. So express this energy in joules. So what we say is that energy is equals to EV, that is electronic charge multiplied by the velocity, which is equals to, now we take 1.6 times 10 to power minus 19 and we multiply by 2.21 EV, and when you multiply this, you can use your calculator, you'll be able to get 3 point, that is you get 3 point, not 3, 3.5, 3.54 multiplied by 10 to power minus 19. So that's how you get the energy. Part 2, determine the frequency of the light that produces the photon. So we say energy is equals to HF, implying that F is equals to A divided by H, which we get, we have already calculated the energy in part 1, so this is equals to 3.54 multiplied by 10 to power minus 19, and this is divided by 6.63 multiplied by 10 to power 34, that is minus, that is H, Planck constant, which will give us 5.33 multiplied by 10 to power 14, and the symbol here is Hertz. So that is how you work out that, and you get 1 mark here and you get 2 marks here. So that's how you work out that part, which brings us to the end of that paper.